how to monitor machine learning in scale, or how to discover problems before your customers do. That was exactly your question previously in the previous presentation. So we basically we will cover the ways to monitor machine learning in production, and we will show you a demo of how do we do it in Salesforce. So first, let's begin with a little explanation about our automated AI in Salesforce. Eleanor has covered it, some aspect of it, but I want to cover it from different angle. So probably you are wondering why Einstein is here. So Einstein is actually the name of all of our AI solutions in Salesforce. So you probably are familiar with the classical approach to machine learning and to AI. You have some problem, you want to gather the data related to this problem. Sometimes it's really difficult task. And then you want to try different models on your data. You want to evaluate it in order to choose the right model. But we're doing it all automatically. So we have turnkey automated AI, and we have thousands of customers. As Igor mentioned in the first presentation, Salesforce has over 100,000 of clients. So think about how much models we're training in production. Every customer is very different, as Eleanor mentioned. Salesforce has different customers, from clothes stores to Amazon to insurance company to banks, cell providers, and so on. So every customer is really different, and that's why we're training separate model for every customer. It results in thousands of models in production. So I think some of you has already understood why do we need monitoring, why it's so important to us. And I want to show you another example of product in Salesforce, the opportunity scoring product. So Einstein Opportunity Scoring is a product to help sales reps to do their work. Imagine yourself calling to a cell provider. You want to buy their services. You want to ask about the price, about how to transfer to them. So when the sales reps is answering your call, they open an object and fill all the data you're providing into this object. This object is called opportunity. So it's basically the sales deal that the sales rep is working on. So a sales rep is getting lots of calls per day and lots of requests from the web. So he's dealing with hundreds and sometimes even thousands of opportunities simultaneously. Until opportunity scoring, every sales rep was prioritizing his work, only using his gut feel. And now with opportunity scoring, we're helping the sales rep to prioritize his work. So similar to lead scoring, we're providing scores, and the sales reps can rank the opportunities based on the scores. Together with scores, we're presenting the explanation of these scores. From our experience, sales reps find it hard to rely on the scores. They are not data scientists, and they are not familiar with computer science, so they don't trust a generated score by a machine. So that's why we're providing this explanation. So basically, how does it work? It's important for you to remember that all the data we're using, it's human-generated data. So it can be very noisy and very hard to train machine learning model on it. So we're using the opportunity object to train models, and we are using standard fields, and also every customer of Salesforce can create his own views and his own fields. So we're using customized data as well. Our labels here are won for opportunities that the sales rep managed to close and sell the product, and lost for the opportunities that the sales rep couldn't close and sell the product. So we're training a model every 10 days, similar to lead scoring, because we became to the knowledge that 10 days is enough and is necessary because the customer data is changing. Think about your workplace. How many reorganization did you have? How many movement between teams? And so on. So the data is changing all the time, and that's why we have to train our models frequently. And in the end, we're providing the scores and the reasons to the customer. So I think you have understand the motivation. We have thousands of models running in production. All our data is human generated, and we have all the overhead that Elinor explained before. So our motivation is we want an easy-to-use tool to help us to discover global issues in the product. If, for example, we enter the code to production that caused a degradation in lots of models in production. And the second thing, we want to be able to actually research a specific model in production. If because of the customer is approaching us, or because we identify his model is running not as expected and he doesn't have a good quality model, so I want to research it. So we need an easy-to-use tool, scalable tool, a tool where all the metrics are represented in one place, and one of the most important things, we need an alert system. We need a system that will alert us on every degradation in the production. So after we covered the motivation, I want to talk about our approach to monitoring our machine learning models in production. So we defined a term, it's a healthy model term, and we define it by 3 different categories. The first category is data shape. We don't have a control about the data that we're receiving from the user, from the customer. So we need to identify customers that we can train a model for and that we can't do it. So we want to check if the customer meets our expectations. The second thing is runtime health. Like every application in production, we want to see if there are errors in production and monitor it. The third thing is quality health. Here we're monitoring the quality of each model in production. So let's deep dive into each of the categories and see examples of metrics you can use. So for data shape, there are lots of ways to measure these things. One thing is data size. The other thing is bias in the data, if the classes are extremely unbalanced. The third thing is noisy or very sparse data. So in Salesforce, these challenges are translated to these examples. So sometimes sales reps are not closing lost opportunities at all. They are only closed won opportunities in order for their managers to see their revenue, but they don't always have the motivation to close lost opportunity. So then we receive data with only one label, and we can train a model on this data. The second thing, as I described before, all our data is generated by humans. So sometimes sales rep don't fill all the data they need to fill into the opportunity object, or they fill all the data retroactively. Only when the sales rep is closing the deal, he fills all the fields. And then we don't have any history about the opportunity. So think about your applications and how you can measure data shape. The second thing is runtime health. As I told you before, we want to discover errors in production, but the other thing on top of that, we have defined SLAs for products. So these are examples. First of all, we want to ensure that all the pipeline steps are running properly. The second thing, we want to provide an experience to the user where the scores are changing due to changes he makes in the opportunity object. So that's why we need to score the opportunities again many times per day, and at least 4 times per day according to our SLA. The third thing is model aging. As I described, there are lots of changes in the opportunities or in the way the organizations are working, and that's why we don't want the models to age. Another thing I want to mention, that if we have our customers with bad data shape, we won't monitor their runtime health. And that's why we filter a lot of noise from our monitoring system. The third category is quality health. You have a lot of ways to monitor the quality of your models. We have to monitor the quality of 2 products that are running together, the scores and the reasons. For the client, it's 2 different products that he is getting. So you need to choose your metrics based on the experience that you want your customers to have. So I described before the scenario when the sales rep is ranking the opportunities based on the scores. So we are basically dealing with ranking problem. That's why we chose AUPR as our metric, because it is a very good metric for ranking. But it became clear to us that the sales reps, it's nice to prioritize the work and all, but when the sales reps is coming and closing the deal, and he's closing the deal as 1, he's expecting to see the score of 80 at least, and not a score low as 40, even if this the highest score for his organization. So that's why we're using also Brier score. For the reasons quality, the most important thing for us is to present the more variety and quantity of reasons. So if the sales rep is seeing the same reason over and over again, he will lose trust on the system. And if the sales rep is seeing small amount of reasons, he will also lose trust on the system. So that's why both of these things are important. Let's look at some code examples. First, we're looking at the AUPR code example. We're using scikit-learn for calculating this metric. We're calculating the precision numerical graph for each model, and then we're calculating the area under this graph. The second example is the Brier score code example. It's important for us to divide between the won opportunities and the lost opportunities when measuring Brier score, because if the data is unbalanced, we can hide problems if we're measuring all of the data together. So thank you. I want to invite Naama to present you the demo.
So after we understand the main concept of the model health system to monitoring AI in scale, let's deep dive into the demo and to see how we can use those 3 categories, org shape, runtime health, and quality health in order to actually identify issue and bugs. Before we will start, I want to emphasize all the data that present here in the demo is simulated and it's not a real customer data, yet it represents the customer data as close as possible. So let's take a look. Okay, this is our main page. This is the dashboard, and you can see it contains 4 different tabs. Each tab has its own functionality, and we are going to cover it during this demo. The main tab, the Model Health tab, starts with a summary. This summary gives us the status of our system regarding the model health category. We can see how many issues we have in each one of the category, and it helps us to focus where the problem and where we need to prioritize our work. It's easy to see that we are experiencing a lot of quality issue. Almost 20% of our tenant, our customer, have some quality issue in their models. So if I will open this dashboard in the morning, I immediately start to investigate it, and let's do it together now. In order to understand what's happening, we can use the Py section. It helps us to break down the issue itself by the reasons for each one of the categories. So we want to focus on the quality issue, so let's increase the Py for the quality reasons. And here we see really clearly that the main problem in our system right now is happening due to the STD. The STD is the standard deviation, this measurement represents the diversity of the scores that we give to a customer. It's really important for us that a customer will get various of score in order that he can actually use it to prioritize his work, because this is what this product gives him. Situation where, for example, we give for a customer scores between 50 to 60 is just not informative enough, and we considered it as a bad quality. Of course, that if you use this system, you need to think what is a bad quality for your product and your demand. Okay, so we know we have a global system issue because we saw that more than 20% have quality issue, and we know it's related to the STD. In order to understand what's exactly happening, we can continue to the trending tab, the second one, that gives us also the summary and the status of the 3 categories in our system, but this time it gives us a view over time. We can see the change from last day. And here we can see that we have a huge increase, huge rise in the number of issues with our quality. So we want to investigate it, and before we get inside the STD metrics, I want to explain about this graph, the overtime graph. Here you can see aggregate measurement for all the important quality and runtime measurement that we define to our product, to opportunity scoring. Aggregate over all the customers in our system, and this is the 20 percentile measurement for all the tenants. For each metrics, we have a threshold. The threshold is the value when the 20 percentiles for all the tenants is crossed it, we immediately get notification to our Slack in order to notify us that there is a global issue in the problem, in the system. So each metrics have different threshold. Some of the metrics we want to maximize, some to minimize. This is why the threshold is up or above the value. But this is the main concept here. Let's take a look at the STD graph and see what's happening here. It's really clear that we are experiencing huge drop from yesterday. One thing is to open a bug and go home, but if you are a little bit responsible, I guess you're not going to do it. And most of the people, the company, I guess will, I'm sorry, I forgot to tell you that yesterday, it's not just we have a drop, yesterday we had a promotion. And we think this is happening due to promotion. So most of the people will do some rollback and go to the old version of the code in order to prevent this regression. But luckily for us, we don't need to do this for all the changes we added to the promotion. We can just continue and use our dashboard and go back to the model health tab and look at the table that gives us all the data regarding the customers, for all the customers in our system. Here we're filtering only on the customer with the STD problem, and we can see that all of them are shared the same configuration. Configuration in our model is the hyperparameter that's chosen for the AI model, the machine learning model, for this customer. Like Anna told you, each customer has its own model, And sometimes it can be random forest, like here, or it can be XG boosting or something else. And each one of them have different configuration that's chosen automatically during our flow. We can see here that all of them are sharing the same configuration. And it's quite clear that this is what's happening to the problem. So, of course, after we saw this thing, we immediately remove the configuration. We don't need to go back to the old version. We can just remove this configuration and retrain those models. And most importantly, we check those configuration on research, but sometimes bugs happen. We cannot prevent them to happen. And this tool helps us to discover this. I did with you in 5 minutes. Without you, I would do it in 2 minutes. Immediately, I discover what's happening without giving continuous damage to my customer and without getting any complaint from customer that see only a score between 50 or 60. So we couldn't do it without this dashboard. But I want to show you another example. This was an example for how we use it to discover a global issue in our system. But how we do it when we want to find specific model issue, because every customer has its own model, I will remind you. So we got notification, like I told you. We have also notification for specific model, and we got notification about 3 customers that cross the threshold for the AUPR. They have really extreme AUPR. I immediately go to the dashboard, but this time, because I know the tenant ID, the customer ID, that having the issue, I am going to the breakdown by tenant tab. This tab gives me all the information about the shape, runtime, usage, quality, everything that I can find in my system on the specific tenant, specific customer. I filtering on the customer that I got in the Slack notification, and I can see immediately that he actually have a quality issue regarding to the AUPR. I can see another 2 things. The first one is the score histogram and the win rate. You can see here that the score histogram, the distribution of the score that this specific customer have, is really biased, unbalanced, and almost all the score I give him is close to 0. Also, you can see it correlated with the win rate, the really low win rate. In our system, win rate is the ratio between the closed opportunity that closed as 1, dividing by all the closed opportunity. So we can see those two metrics are really unbalanced and really weird, and it's suspicious. But we can see something even more interesting. We can see that this customer have almost 1,000 filtered opportunity. Filtered opportunity is a feature we have in our system that gives the customer the ability to use his prior knowledge about the data and to filter opportunity from influence the model. I will give you an example. For example, you have data and you know that some group of the opportunity are behave differently from the other opportunity. And you don't want that this kind of opportunity will influence on all the model. So the customer can just filter it without asking us by himself and using his data, his idea, his knowledge to improve the model. And here we see that the customer actually filter, but he filter so many opportunity, like 30% from all the closed opportunity. It's a lot and it's really not normal behavior. So I want to see what's happening yesterday or a few days before, because just today I got this notification. So I will filter the dashboard to the day before, and now everything looks differently. The score histogram and the win rate become normal and they are balanced. And more importantly, I really don't have any filter opportunity. So from this thing, I can see that the filtering that my customer added to the dashboard, to his model, is actually affected both the quality health, because the AUPR, and the org shape, because the win rate become really unbalanced. You can see how the win rate behave until the filtering and since the filtering. So of course, after this, I immediately notify my customer about the issue with his filtering, and I want you to think about it. This customer, probably in the US, before he went to his home, he added some amazing filter he thought to his AI model. Until he wake up, I already discovered that this filtering is ruining his model and notify him about it. And I did everything while I use handling thousands of customers and found this specific problem in this specific model. And I couldn't done it without this tool and the automatical monitoring thing. So I hope we convince you that monitoring AI is important, and we hope you can think how you can use the model health to use in your product. And thank you.